Draw a Venn diagram and use the given information to fill in the number of elements in each region. So we're given the number of elements in the set A, the number of elements in the set B, the number of elements in their union, and then the number of elements that are in the complement of A. So right now we know we have two sets. So I'm going to go ahead and draw my Venn, start it with set A and set B. And we're going to draw them overlapping because right now we don't know if there's anything in the intersection or not. Okay. So when we're filling in our numbers, if we try to start here, like the number of elements in A is 19, we don't know where to put them. We know that they're going to have to all belong inside A, but we don't know if they go here, here, or most likely some are in each spot, so it could be like 10 here and 9 here. We just don't know right now. So that's really the first thing that we have to figure out. And the same thing goes for the set B. So usually we like to go ahead and start with what is in the intersection. What is in this region right here? We're not given that information. So let's see if we can figure out what it is. Now, right now, the information we have, think about if there's any formulas we know that involve, the cardinality of sets, union, intersection, especially the intersection since we're trying to find that. And we do know that the number of elements in A plus the number of elements in the set B minus the number of elements in their intersection will give me the number of elements in their union. Okay, so the number of A plus the number of B minus the number in their intersection equals the number in the union. So we're going to go ahead and use that formula to solve for the intersection. Okay, so setting this up, it's like an algebra problem now. We know the number of elements in A, that's 19. The number of elements in the set B we're given, that's 13. We don't know how many are in the intersection, that's what we're looking for. So I'm going to let that be my variable x. And then how many are in the union, that was also given, that's 25. And now we can go ahead and solve this for x. So adding together my my like terms over here, I get 19 plus 13, we'll have 32. So 32 minus x equals 25. There's a couple different ways about solving this. I'm just going to go ahead and bring the 32 over. So subtracting 32 from both sides, we'll have a negative x equals a negative 7. And so that means a positive x must equal positive 7. And if you want, you can divide both sides by 1 or multiply by negative 1 to get x equals a 7. So that means the intersection, A intersect with B, it's got 7 elements in it. So perfect. Now I know 7 goes here. We can fill out the rest. So coming back now to A, we know it has a total of 19. So between here and here has to be 19. We've already got 7 of them there, so 12 goes here. So 19 minus 7 gives me my 12. For the number of elements in B, we know that has to be 13. So again, here and here has to total 13. We've already got 7. So 13 minus 7 gives me 6. Okay, we're almost done. I don't know how many elements are, outside of the, the two sets, but still part of the universal set. So I need to figure out what goes, out here. I also haven't used this information yet. So what's not in A is going to have to equal 11. Now I can't exactly do this here with my finger, but if you cover up everything that's in the set A. Okay, so let's say I cover up, let's see, I can do this here. So everything that's not in A, so if you kind of cover up A, I would do that with my hand, and what's left? I have the 6, and then I have, that part that's outside of the circles. That has to total 11. So that means here I have, 6, these two have to total 11, sorry, not 4, 5. 5 has to go here, so 6 plus 5 is 11. All right, so that's how you can fill in all the areas. Like I said, always want to start with the intersection if you can and work our way out.